Hello, and thank you for joining in. Today, I'll be talking about Qubesome, GitOps, and how that can help you manage your dot files, pretty much running your window manager and your workloads in non-root containers. First of all, I'm Paulo Gomes. I'm a security engineer in the runtime security team at SUSE. I'm passionate about security, Git, Golang, and Kubernetes. I also am a maintainer of Qubesome and GoGit. Today we'll be talking a bit about what is Qubesome and why I use it, and also around how managing window managers and workloads in containers can be beneficial, especially in a GitOps manner, and then dive into the architecture and security model for Qubesome, and also cover things like what Qubesome could improve in the future. So what is Qubesome? Qubesome is a CLI. It helps you manage your dot files, which would then be running on non-root containers. Why is that needed? Well, it's kind of easy to run, workloads in containers, especially like your UI apps and stuff. But what I wanted at the time before I created Qubesome was something that would tie it all together and make it kind of straightforward to manage everything in a GitOps way, pretty much how you would do with your workloads and Kubernetes. Some things that this can help you with is things like have more reproducible end-to-end setups. So for example, your window manager has a container image that contains all the packages it needs to run. Then you have all your settings in a Git repository, and then you can just run that on demand. Same way you can share that with other people. So instead of just saying here are my dot files, try to find all the packages for your distribution and try to use it. This is more like you kind of point in and fire, really. You point and shoot. Linux window managers are quite interesting. They have there are a ton of options out there. You can customize it as much as you want, really. And on that pursuit of kind of building your own window manager and configuring it to your pleasure, it can be quite a long task, really. Like you can be doing that for hours and hours and hours. One thing that is quite hard at times is when you have to test some of those settings. So for example, when I first started with Awesome Window Manager, which has all its configurations using Lua, I wouldn't know Lua very much at the time, which meant that some of the errors that I would make or some mistakes, and I tried to reload the configuration as I was using Awesome, it would just kind of break the setup, and sometimes I had to kind of restart the machine to kind of get back to a better state. So one thing that is quite interesting about running window managers as containers, especially in a GitOps manner, is that you can set up that as you're running your setup, right? Like so you kind of have a whole different setup that you're changing as you go, and you test it several times. Once you're happy, you commit to that, and then you can again just push that to your repository and then use that going forwards. So it's kind of easier. Obviously, you can also do that if you just have a normal .files. The difference here is that you can spin up that instance of your window manager as a container, test it, close it, in literally seconds, again, because it's a container. Other things to think about is window managers, they run in a lot higher privilege mode than it needs because a lot of times it runs on the context of the user. It has access to all the Xorg, which means you don't have really much isolation. Running as containers means that we are able to do a lot around that. We can run on a non-root user. We can limit the access to files. We can run that a lot less privileged and even have like an isolated Xorg, as we'll cover later. So let's start by taking a look on the sample.files. These are normal .files. The main difference is that you have a qubesome.config. So if we open that file, you'll be able to see a few things, right? So the first one are the different profiles. So the names can be arbitrary. You set whatever name you want to call them. You can set a display, which then provides the isolation. What in window manager you want to execute. So Qubesome would execute these commands when, at the time of load. So you can see that although both are using the same images, one would run i3 window manager and the other one would run Awesome. Other things to note is the path. This path defines where the workloads will be created, right? So here are the workloads of this profile. we'll get into that in a bit more detail later. And the key thing that you need to think about is the things that will run within that window manager will be there. That's it. There are a few other things we can do, which we'll cover later as well. Then we have the host access. The host access here is what access does the workloads within this profile have access to, right? So for example, do they need access to dbus? Do they need access to camera, microphone, speakers, and so on? If you block something here, no workload would have access to it, right? And the same goes to, for example, paths and MIME handling, which we'll cover in more details later. The paths at a profile level, they are about what are you mapping into the profile, right? So for example, on my awesome profile, I have the awesome directory from my Git directory, right? So awesome on the .config awesome will be mapped as my .config awesome, which effectively loads all the settings of my window manager. Similarly here for my i3, I have, well, actually I'm loading the default one there, and I'm actually mapping the entire .config across, which is slightly different setup. But yeah, that's pretty much that. So what I will do is let's run that. So Qubesome starts, and let's run awesome, and also let's do an i3 and show them side to side. So yeah, there we go. So you have both of those window managers side by side. Again, if I made any change to the setting, I could literally just close the setting, close the container here, and be able to see what's happening on the changes on demand, right? I can just reopen them as many times as I want. Other things to think about is within each one of them, I don't have Docker, I don't have Podman, which means I can't start new containers, I can't create the workloads directly within this container, right? It also doesn't have access to many things on disk. But for example, if I want to see my run here, for example, I don't have access to the container endpoint. I don't have access, sorry, to the container runtime sockets. Other things to think about as well is within each one of those window managers, I have a different display, and that display would then be available for the applications within it. Yeah, so that is that. Let's quickly see another thing here, which are the applications. So these are pretty much the two containers, one running the i3, the other one running awesome. We'll cover how you can do things within them later, but the core of it is pretty much that. Things to note is, let's close this for the time being. So the workloads that I have on my workloads there is pretty much the ones that would be appearing here. Obviously, as you're mapping your configuration into this container, you could actually change that and add more things if you wanted to. Again, this is completely configurable, right? As long as you know what you're doing, this will just work, which is easier said than done. Yeah, so this is the core of the window manager, right? It runs in containers. There are no root users. If we just go back quickly there, these are different. There are different containers. You can see by the ID of them there, and then both of them are running as non-root. In terms of benefits of running window managers as containers, there are a few, as I mentioned before. They are more reproducible because, again, you have all the packages it needs, all the applications that will be into a container image, which you can version, and then you can have all your configuration on a Git repository, which again, you can have your commits and stuff. Those two things together means that you be able to run that virtually anywhere. You have great isolation. After all, you're running that as non-root user. That could be a different user than yours, if you so wanted, and can also restrict the access of that container. So for example, it doesn't need to have access to your personal files, doesn't need to have access to internet, for example, or you can limit the internet to the internet access it has. Another thing that is worth mentioning is cross distros, because again, you have that container that contains all the things you need to run your window manager, which means you can run this setup on any other distro, it should just work. As long as you have, container runtime, you should be all right. You have things as well, such as support to Wayland. So for example, you can run these Xorg apps and window managers even if you have Wayland on your machine. And also different platforms, right? So for example, I run this quite a lot in Leap and Tumbleweed, but I also have a work colleague, Nuno, who run Qubesome on Windows. I think it was a Windows 11 with WSL2, and that worked absolutely fine. In terms of Mac OS, this should also work. My understanding is if you run Xquartz, no, I think it's just Xquartz, you would be able to get this to work as well with no issues. Let's talk about workloads. They are slightly different than window managers. And the reason being is workloads need a bit more privileges, right? Because after all, they can be a bit more powerful applications, they might require more access and so on. But one thing that is quite beneficial for running workloads in containers is that, especially with Qubesome, is that you can have different settings and access depending on the profile, right? So imagine you have a profile for personal stuff and then for work stuff, and they have completely different storage, attached to them, which means when you download something for personal, that is never available on your work stuff and vice versa. So for example, imagine if you download something on your Chrome for work, that would not be accessible from your personal and vice versa. You can do kind of levels of isolation within the Chrome itself, like creating different Chrome profiles, like the default from Chrome itself. But on this case, you're actually limiting at a kind of container isolation perspective. The same would apply for other things, like for example VS Code. I like having the history and my setup configurations and stuff for work and personal completely different, which means I can close all my kind of work-related stuff at once, and I know that tomorrow when I kind of open that again, it will be exactly as it was, regardless if later on I'm kind of doing some hobby projects and I kind of open different projects, different setups. It doesn't matter. My history in one does not kind of meant or get affected by the other. All right. Same goes for internet access, but we'll kind of cover that a bit more later. It's also interesting to remember that Qubesome is not the first thing to kind of create and run workloads in containers. From a UI perspective, the key difference is that it tries to go as GitOps as possible and also provide different levels of isolation, which you configure on your declarative state as well. But to kind of be true to the title of this talk, for you to be able to never set up a machine again, you need to make sure that your configuration is kind of separated from your data, right? So you would have the container images for your workloads, you would have the settings of your workloads and configuration on your Git, and then the actual persistent data would be isolated and ideally on an external drive, for example, which can be, looks encrypted as well, which again, you get all the benefits of, having that encrypted and all, but also having the portability of just jumping between machines if you so wanted. One thing to kind of bear in mind as well is that you do not want to put your data mixed with your Git estate, right? And the reason for this is, first, because you don't want any like cookies or sensitive information to kind of be into your Git history, but also it just makes it a lot harder for you to share. It creates like a lot of security concerns as well. But we'll kind of cover that in more details now. Okay, we have our setup here, so let's close these two commands and well, let's for example open our Chrome application here, right? If we go to the configuration of that Chrome, so we are awesome, and let's close this Chrome. It doesn't have any setting on the paths, which means there's no persistent paths into this workload, right? That means that this workload is completely ephemeral. So if I go here and kind of go to github.com, that would be on my history here, github.com. But then if I close this, and open that again, there's nothing. Because again, there's nothing mapped to that workload, and that will make everything to die as soon as the container dies. So that is quite interesting from a kind of context perspective, and I'll show more in details later. If we go to back here, other things to think about is you can configure your devices and access to specific host configurations, right? There are more things around how you're running that application, but that kind of goes a bit beyond this. Let's just kind of switch gears slightly and just notice a few things, right? So I said I don't have Docker access, right? So how does these things work? How can I, within a container that is my window manager, how can I run this other application, this other workload, which actually is running in a container? And I'll show that in a bit more detail in a minute. But before we go there, I can just go here and say, for example, Qubesome run Chrome, and that will run Chrome, right? So this window manager, it has a connection with the process that run the window manager from the host, and all the workloads for this specific window manager are allowed, which means I can literally just run them within this window manager without having any access to the host, right? So just to make things a lot easier, I'm going to close that and open this. So I have a Chrome application here. If I do Docker PS, it would be here from Awesome. So the application Chrome, or the workload from on the Awesome profile, right? So that is kind of how things would work. You're pretty much getting a new container for that given workload. There are other workloads. For example, there is one for a CLI here, which would be the same thing. So you can kind of go back there. Docker PS, you would have the CLI. Other thing to kind of notice as well, for best experience, use the grabber shortcuts. Why is that, right? So all of this is running, like on my host, I have also window manager, right? And in this case is also the awesome window manager. So if I do, the window R, I would get all the settings or all the applications configured for my host application. But then if I grab the keyboard and mouse within this window manager, I can then, I can then run this directly from there. All right. Okay. So that is the core of like kind of applications and stuff. One thing that we can also notice is, so imagine that I have things that are not running containers, like some given workloads that I do not have anywhere else, but I want to run within this window manager. How would I do that? I would be able to do that by Qubesome host run. I cannot do that from inside the window manager, right? Because otherwise I would be able to do anything in the host machine. This needs to come from the host into the window manager. So I'll run that into the profile Awesome, and let's say I want to run that one there. So I'm running this terminal from my host, but in this case is actually running in that given window manager, right? A quick example, now that we're here as well, is there's another runner. So the default runners is for Docker and Podman, but one that is quite experimental at the minute is Firecracker. So I have a Firecracker workload, which what it will do is it will run a kind of container, and that container is a micro VM actually, and it's based off a container image, right? So if I go Chrome here again and just quickly open Qubesome, github.com, Qubesome workload images. So the image that is running there would be the micro VM image, which would be configured on this sample. I'll show the sample on my other window in a second. But basically, this is an Alpine image, which it pretty much gets executed on demand here. And this, whatever is the content of this container image, it will become the root FS of this micro VM. Again, this is still experimental. Is mostly for terminal. I haven't run anything on Firecracker that then provides a CLI, GUI. So that is still experimental. It's still early days. Right. So that is that. So let's close this. The Firecracker example is pretty much here, and what it has is, again, just defines the image. It has a lot less settings because it's quite experimental. You can't map directories and stuff yet, but the idea is just kind of get an initial runner running so that it's easier to get a micro VM running out of kind of a GitOps setup. Right, so in terms of architecture, let's just kind of try to see this a bit more into detail, right? So when we did a Qubesome start, it would get a .files, which would be either in a local directory or on a remote Git repository. It will talk with Docker or Podman and run and create that container called Qubesome i3, right? In this case, we're doing a Qubesome start i3. Within that container, you would have a version of Qubesome. It would be the exact same version as you have on your local host. You'll be able to do two different types of commands there, which would be Qubesome run or Qubesome xdg open, which would handle MIME types. And then you have Zephyr. Zephyr here would pretty much just create an isolated display. So if you have different profiles and those profiles have different displays, like the one in the example I showed earlier, they would have the isolation of displays. We'll cover a bit more of that in a second. Then within that window manager, I will do a Qubesome run Chrome. That would cause a new Chrome container to be created. So the name would be Chrome i3, which is a workload Chrome on the i3 profile. Within this container, you would mostly have the application that you want, in this case Chrome, and if you have enabled MIME handling on the host access, that will also support what we call Qubesome xdg open, right? This talks back to Qubesome, which it kind of will leave like a gRPC socket on the host. This is MTLS enforced, which means you need that kind of the certs to be able to communicate back with Qubesome, and that is not stored in disk. With this in mind, other things to consider and to think about is that workload would only have access to storage that you map to it, and that storage is restricted to whatever you set at a profile level, as we discussed. The same thing goes to USB devices. The Xorg display that is mapped into Chrome i3 is only the one that this profile has, right? So imagine that you have 10 displays. So you have 0, which is your host, and then you have 1 to 9. And this specific profile has display 1. The only display that is mapped into this container would be the display 1, right? That is it. So let's quickly see that in action. If you look at the Qubesome config of that sample.files, we have here that the profiles can access MIME, and then if we go to Chrome on that profile as well, we can see that MIME can be handled, right? There's nothing configured. So if we go here, let's just do Qubesome run Chrome. So that run the application. We're back on the host here, so let's just do an exec into that. And if we did Qubesome xdg open, and let's say that we had a link to Slack, ABC, whatever, right? It's saying cannot handle MIME type. Slack, the MIME type is not configured, nor is the default MIME handler, right? Okay, so if we go back to our configuration here, and we save this configuration, so we pretty much just save it locally. and we were to reload this profile, so let's Qubesome start, yeah, and then let's run that Chrome there. Let's go into the application again, docker exec, and then if we did the same thing again, so Qubesome xdg open slack abc, what that will do is it will run a new Slack and send that to it. So for example, if you have on this specific Chrome, you want to be able to open, like you have your Chrome, you have your Slack open on Chrome, and then you have like open in app. This is how it would be handled pretty much via mine, right? So yeah, that's pretty much that. In terms of the security model, the window managers or the profiles, they would be running with all capabilities dropped, the no new privilege flag enabled as a non-root user with limited access to disk. As I showed before, the disk access is mounted based on the configuration that you set on your Qubesome config. The runners are pretty much Docker and Podman. When it comes down to isolation of the displays, if you have a different display ID on different profiles, what will happen is screen, clipboard, mouse would be, and keyboard would be isolated. I will show that in a second, but pretty much if you share the same display ID, you won't have that kind of isolation. If you have that different, for example, if you are doing a presentation and you're sharing your entire screen, you will be limited to the display that you set. So for example, if you're on personal, you won't be able to display any content that is within work and vice versa. For clipboards, there is a subcommand on Qubesome that would help kind of sharing that across, but otherwise you won't kind of have that access across. When it comes down to the security model of the workloads, they are running also as no new privileges flag enabled, no root user, and the access to this is limited, is based on whatever you mount. Then there's both Docker and Podman as runners, and Firecracker as we mentioned before. To show an example of the isolation that I just talked about, I will run both again in parallel. So we have Awesome, and we have i3. I'm going to run Chrome on each one of those, and then what I will do is try to share the clipboard, right? So if here I type Qubesome i3, Control X, and then I come here, Control V, sorry, it would not even be available, right? If I do Qubesome Awesome, again, try to copy and paste, it will paste what is here, but if I come back to i3, I still have what I had before. Those clipboards are isolated. If I wanted to share, I could be able to come here, for example, Qubesome clipboard from profile, and then pretty much, let's say I want from i3 to awesome. I don't remember that syntax here. There we go. And then basically I copy to awesome, right? So if I come here and Control V now I have that clipboard, right? So again, that isolation is optional, but if you want it, it's there. So you can pretty much be within the context or profile that you want. As I mentioned before, given that everything is running as containers, that means that you have a lot more flexibility and you can play with the network a lot more than you would otherwise. So for example, here on my personal setup, one of the things I have is a gateway YAML file. So I have a component that is not public yet, but that's something that I'm kind of working on the UX before I make that available. But what I can do there is per workload, like per workload name, I can define what DNS queries are allowed, which ones are blocked, and whether or not I want to block any DNS query that is not really set here. That way, I have a lot more control in terms of what is accessible on a given workload and what isn't. So if I want to test if a given workload is trying to reach out to the internet out there, I will be able to kind of see the DNS queries quite easily. But again, this is still very early stages. It's not available or quite easily usable yet. That brings me to ideas for the future. In terms of the UX and documentation, that is a big one. I have been using Qubesome for about 2 to 3 years. It started as a bunch of bash files, and now it's a CLI. But there's still a lot of UX and documentation that needs to be in place. Granular dbus access control is something that is definitely on the cards at the moment. You either have access to dbus or you don't. If you do, you have access to all, which is not great. As I mentioned briefly now on the network controls, today, there is kind of ways of doing DNS handling to block for a given workload. But what I want to do in the future is expand that to egress, for example. So even if you don't have, even if you don't need to do a DNS query and you're just egressing, be able to kind of block that in an easy and kind of GitOps manner. The storage at the minute, I only support what I use, which is Lux encrypted external drivers, external drives. But in the future, what things that could see there is, for example, a support of cloud storage. And then there's refactoring and API review. A lot of that matured over time, but it could still have some tidying up to do and maturing. And this is it really. So Qubesome is available built in on both Tumbleweed and Leap. You can just do a zipper in Qubesome. If you have any, feedback or any questions, you feel free to reach out on Discord server below, or just open a new thread, a new discussion on GitHub. Otherwise, that's it. Thank you very much. Cheers.